Okay. All right, so we've already said that a larger mass needs a greater force to move. And so we're going to be using force equals mass times acceleration. What does acceleration mean? Yeah, movement. And specifically, acceleration is going faster, it's changing our velocity. So let's think for just a second. What do we measure force in? What units are we looking for? That's not force. Newtons are force. Okay. kg is mass. So we are going to look for kg when we're doing this. And acceleration is meters per second squared. Notice this is the same unit as gravity. Because gravity is an acceleration towards the mass of Earth. Give me a thumbs up if you feel like you can handle this equation pretty easily. Okay. All right, let's do some practice problems. We're going to come down to our lesson, find the practice problems. We'll do several of them together, and then I'll ask you to do some on your own. So let's kind of get our worksheet together. All right. So the first one here, it gives us kind of what we've been looking at. We've had some different objects. So in our notebook, we're going to go ahead and draw the scenario that we have. So we have a box that has a mass of 4 kilograms. It has an applied force of 30 newtons to the right and a force of 10 newtons to the left. Okay. We have to find the net force first. So what is the net force on this object? Let's remember, net force is sum of the forces. Right. So we have traditionally said that to the right is positive, so we're going to say 30 newtons plus minus 10 newtons. Now, why is the 10 negative? It's going the opposite direction. That's right. So we're going to actually end up with 20 newtons to the right because that was a positive number. All right, so now we have force. If we look at our problem right here, it's asking us for acceleration. So acceleration equals force over mass. So we'll come down to the next line and we'll go force divided by mass. We're going to use the force that we calculated and the mass from the problem. So what is our acceleration? Right. 5. Now, what unit is our acceleration in? Now, you might say, well, where did meters per second come from? Let's kind of go back and think about newtons for a second. A newton is kilograms times meters per second squared. So when I divide by kilograms, I'm canceling out the kilogram in the newton, and I'm left with my unit of acceleration. So that's important to kind of keep in your head for the right units. Give me a thumbs up if that makes sense to you. Okay, all right, let's do number 2. It's a little bit different, but a little bit the same. Okay, number 2, we have the same question, it's just a different object. And this time our object is 5 kilograms, and we have 2 forces. 4 newtons, and 6 newtons. Tell me about these numbers. Which one of these numbers would be negative? Somebody said neither. Why neither? They're both going in the same direction, so that's correct. Net force is 6 newtons plus positive 4 newtons because they're both going in the same direction. So what is the net force? 6 plus 4 is 10 newtons. And we know that our direction is right because it's a positive number. So then they're asking us for acceleration. We just use that force from the problem up there and the mass from what we're given. Thumbs up if that one was easy. Good. Okay, so we'll skip down and we'll do one that is a little different than that. Let's go ahead and do number 6. Let's notice number 6 is asking us for force. Okay, number 6 is asking, we've given us a mass, it gives us an acceleration, but it's asking for a force. So let's go ahead and do that one. We have this box. Yes, sir. All right, so we have our object. We know there has to be a force on it because it is accelerating at 2 meters per second squared, but we don't know what the force is. So we're going to just straightforward use our formula. Force equals mass times acceleration. So 8 kilograms times 2 meters per second squared. What is the force? 16 newtons. Because a newton is kilogram meters per second squared. Is that pretty easy? Give me a thumbs up if you feel like you got that. Okay, good. Scroll down. I wanted to do this challenge with you, and then I'll tell you what our shortened homework is. So number 10, the challenge. You're going to have to think through a problem like this on the test, so we want to make sure that you understand how to do them. A student is pushing a 50-kilogram cart with a force of 600 newtons. Another student measures the cart and finds the cart is only accelerating at 3 meters per second squared. How much friction must be acting on the cart? Hint, draw a diagram showing the cart and the two forces. All right, so if I have my cart, okay, and it is 50 kilograms, right? There is a force, so one student is pushing with a force of 600 newtons, and acceleration is 3 meters per second squared. They are asking, what is friction? Okay, what is friction? So how would we do that? If we know that we're using the formula force equals mass times acceleration, my force is the net force. So when I look at the forces I have, I'm going to have 600 newtons plus some negative number. But let's go ahead and assume that we're just doing the sum of forces. 600 newtons plus friction equals our mass, 50 kilograms, times our acceleration. All right, so can you give me a thumbs up if you feel like you can do a problem like that? All right, let's go ahead and finish it then. 150 newtons or kilogram meters per second squared equals 600 newtons plus friction. So how do I get friction by itself? What do I have to do? If this were algebra, how would you get F by itself? How would you find F? Subtract. So minus 600 newtons, minus 600, minus 600 newtons. I'm going to have to scoot over here where I have more space on the paper. Yeah, 450. So friction equals 450 newtons toward the student. Because we don't know if the student is pushing the cart north, south, east, or west, but we know that friction is going against them. Okay? Our friction ended up being a negative number, but we know that negative tells us the direction. All right. All right. So, if you scroll down, there's a second page. On the second page, I would like for you to do the first 4 problems in your notebook. Okay? I would like you to do the first 4 problems in your notebook. I will come and check on them momentarily in a little bit. It should only take you a few minutes.